So here's our introduction to the differentiation. Okay, again, we have this equation. It's the slope of a curve at a point. That limit, if it exists in the form of an equation, is called a derivative, and that's we're doing the same thing we were doing before. We're just doing it with variables. So here, technically, is the definition. The derivative of function f of x with respect to the variable x is the function f prime. This is called f prime. Okay, it's a symbol for derivative, f prime at x, provided the limit exists. Keep in mind the derivative of f prime may have a smaller domain than the domain of f. If f prime exists, we say f of x has a derivative at that point. So if the derivative exists, it exists at that point. Okay, we'd say f prime here. This is just restating the equation that we already know. The domain of f prime may be smaller than the domain of f. If f prime exists, it has a derivative of x. It's the same thing. Okay, so let's take the next one. Now, instead of getting a number, we're going to end up with a function of the variable that we can use to find the value of the slope at any point along. In the last section, every time we wanted to find at a different point, we had to redo the whole equation. Now we don't. Once we have this equation, we don't have to reinvent the wheel. We just have to keep plugging in the numbers. So let's see how this works. So we're going to find the limit as h approaches 0 of x plus h over x plus h minus 1. Okay, everywhere there was an x, I put an x plus h, minus x over x minus 1 all over h. What? No way. Yeah, that's the equation we have to work with. So now, yes, we get to do fractions, and yes, we get to find a common denominator. That's an h. Okay, so my common denominator is the product. So now I have the limit as h approaches 0. I multiply that times that, so x plus h times x minus 1 minus x times x plus h minus 1 all over x minus 1 times x plus h minus 1. Again, all of that over h. Whew. Yuck. Okay, so from here to here, I just found my common denominator. That's not so horrible if I just let them be multiples and be done with it. Okay, so far so good. Okay, so now I got to do some math. Yay, some math. So now I have the limit as h approaches 0. Multiplying that out, I get x squared plus hx minus x minus h minus x squared minus xh plus x over my common denominator, x minus 1, x plus h minus 1, and I'm going to multiply by 1 over h to get rid of that sucker. Okay, I did this multiplication, and this is what I ended up with. Check my math there. Does that all make sense?
Why do you have to multiply by 1 over h?
Instead of dividing by h, I'm going to multiply by 1 over h so I can cancel it. So I could have that h down here again, but I don't want it down here. I want to get rid of it, so I'm going to put it over here as 1 over h. Okay, so far so good? All right, so now we can clean up what we can clean up. Let me grab a different color. Oh, we'll use blue, I guess. Okay, there's a minus x squared, there's a plus x squared. There's a plus x and a minus x. Everything else has an h in it, so I'm going to cancel that h, I'm going to cancel that h, I'm going to cancel that h, and I'm going to cancel that h. Whoa.
Did you cancel the plus hx and the minus xh?
Yes, yes, that would go away, and that would go away. Thank you for catching that. So I have this negative h and this positive h, so that makes a -1. So now I have the limit. You are correct. I didn't catch that. You are correct. Limit as h approaches 0, good catch, of -1 over x minus 1 times x plus h minus 1. Whew. Can I plug in 0 now? Yes! And when I do, this guy turns to a 0, so I have -1 over x minus 1 squared. This is my derivative. This is my derivative. It is also the equation for the slope at any point. So to help us understand that, let's take a look on the next page, which happens to be a graph. Okay, need this yet? Are you good? Okay. So let's graph the function. Well, let's find a few points here. Okay. I'm going to write down our equation up here. Our equation was, that pen doesn't work. Our equation was f prime at x is -1 over x minus 1 squared. Okay, I'm just writing, that's what we found right here. I'm just bringing it over to this page for us. Okay, so let's graph the function. All right, let's find a few points here. Ooh, that'll work. There we go. Okay, a few points. Our original equation was okay, this one doesn't want to work. X over x minus 1. That was our original. Okay, so let's find a few points. I'm not sure how I got some of these points. But we'll find out. Okay, so let's pick a value like, well, let's see. We know 1 doesn't work. We know 1 has an asymptote, so I'm going to draw that asymptote in here. There's an asymptote at +1, like so. How about a horizontal asymptote? I know there's a vertical one because that goes to 0. So there's one right here. I know that. How about a horizontal?
No. Yes.
Yeah, there is. X over x would mean, yep, there's one at 1. Correct. So I have an asymptote here. I have another asymptote here. They come in handy. All right. So let's find a few points on the graph then. Our graph is x over x minus 1. So if I pick the point, I don't know, let's start at 2. If I plug 2 in, 2 divided by 1 is 2. If I pick, I don't know, I can't pick 1 because 1's already taken. How about I pick 3? 3 over 2. How about 4 would be 4 over 3. Okay, so it kind of, and if I picked something like 1.5, 1.5 divided by 0.5 would be 3.
We're putting this in the blue equation, right?
In the red equation.
I can't see the red equation.
I'm putting it in the red equation.
Okay.
Okay, let me zoom out.
Oh, okay.
Did that help? Can you see the red equation?
Yes.
Okay, so here are my points. This is in the red. Okay, so my graph looks like this. 2, 2, yep, and goes like this. And over here it does this. Trust me. Oops, it should have gone through there. There we go, right through there. Okay, there's my graph. Okay, everybody cool with that? Trust me, it works. I promise you, I wouldn't lie to you on purpose. All right? So it says, what is the derivative at 0? Well, if I know an equation for the derivative, all I have to do is plug it in. What is f prime at 0? Well, that would be negative 1 over 0 minus 1 squared. So negative 1 over positive 1 is negative 1. So let's look at 0. And when I'm at 0, here I am at 0, right? It says my slope is negative 1. If I drew a line, oh my goodness gracious, tangent to my curve at negative 1, at 0, look, the slope is negative 1. It says, what about x is 2? Well, let's find it. I'm using different colors so you can see it easier. At x is 2, what is the derivative when x is 2? Well, f prime of 2 would be negative 1 over 2 minus 1 squared. 2 minus 1 is 1. 1 squared is 1, so it would be negative 1. Well, that makes sense. Here's my point. If I draw the slope there, that makes sense. How about negative 3? So, yellow doesn't show up very well, but we'll try it. F of negative 3, f prime of negative 3, would be negative 1 over negative 3 minus 1 squared, which would be negative 1 over 16. Am I doing my math okay there? I think so. So at negative 3, negative 1, negative 2, negative 3, it's going to be really shallow. Wow. Yeah, that's pretty close. That looks pretty good. It's still going downhill. Now find the equation of the line tangent at x equals 2. Can we find the line tangent at x equals 2? Well, we know the slope at x equals 2 is negative 1. We know the point is 2, 2. So finding the line is easy. And there's my equation of the line. I'm finding I made a math mistake. Do you see my math mistake?
Isn't it plus 4?
That should be plus 4. I'm looking at it and I'm like, wait, that's not right. Here it is. There it is. Thank you. Yep, that was my silly math mistake. That's what happens when I do math in my head. So you see kind of how all the parts so far are kind of fitting together in this nice little package. We know how to find horizontal asymptotes. We know how to find vertical asymptotes. We know how to graph a function. And now we know how to put the line on there to make the slope look like it's supposed to. This is kind of cool, I think. I don't know about you, but I think it's kind of cool how we can get it all the pieces to fit together. I don't want to mix my notes here. These are these, these are these. I must have stuck mine somewhere else. Probably on the bottom. Okay. All right. Let's see what's on the next page. Oh, goody. We get to do another one. You ready? What's our equation? Our generic equation is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. That is equal to f prime at x. So, everywhere there's an x, I put in an x plus h. So the limit as h approaches 0 of 4 minus x plus h squared minus the whole thing, so that would be 4 plus x squared all over h. I didn't confuse you, I hope. Okay, minus a minus, so we should be good. So I'm just going to expand that. That's going to be 4 minus x squared minus 2xh minus h squared minus 4 plus x squared all over h. I'll slide my paper over here a little bit there. Okay, all I did was expand this and put it all into one equation. Take a breath. Oh my gosh, it's 6 minutes after 10 already. Where does the time go? Where does the time go? Uh-oh, I lost Isaac again. Okay, well, if you see him trying to get back in, let me know. He keeps fading in and out. I think he's got an internet issue or something. I don't know. All right, so I got a positive 4 and a negative 4. I got a positive x squared and a negative x squared. That leaves me those things. So I have the limit as h approaches 0. What do I have left? I have negative 2xh minus h squared over h. Yep, there he is. Got him. Okay, I'm going to get rid of those h's. I'm going to take an h from there, an h from there, and one of those. So now I have the limit as h approaches 0 of negative 2x minus h. But h is 0, so I end up with negative 2x. So my derivative equation, f prime of x, is negative 2x. So far, so good. Let's see what happens when we put this into a graph again. I'm going to slide this up a little bit. I'm going to bring my graph over. I'm going to copy a couple of things down. Okay, my original function is 4 minus x squared, and my derivative function is negative 2x. Okay, just bringing those two pieces of information along for the ride. All right. So first of all, let's graph the function. F of x is 4 minus x squared is a parabola opening down. Good, okay. Has an intercept of a y-intercept of?
0.
Not 0. 4. Yes, it has a y-intercept of 4. So I'm going to go up here to 4. 1, 2, 3, 4. Here it is. And I'm going to come up with some other points here. So I know that if x is 0, y is 4. What if x is 1? I'll just do it down here. So if x is 1, 4 minus 1 is 3. If x is 2, 4 minus 4 is 0. Same thing is true for the negatives, right? So negative 1 would be 3, and negative 2 would also be 0. I just want to know what my graph is going to look like. So I'm going to go here, and I'm going to go here. Okay, so here's my parabola. If I go any further, oh my goodness. 4 minus 9 would be negative 5. 1, 2, 3, 4, 5. 1, 2, 3. So I'd be here and there. It's going to look like this. Here's my graph. Okay. All right. Now, my derivative is negative 2x. So what is the derivative? What is the derivative at 0? Well, that would be negative 2 times 0 or 0. Well, that makes sense. At 0, I'm going to go like this. And every horizontal line has a has a slope of 0. So that makes sense. All right, let's try another one. How about f prime of negative 1? Well, that would be negative 2 times negative 1 or positive 2. So that means that at this point, it would be going up 2 and over 1, which kind of makes sense if I look at that. Here's the line. I'm trying to touch that point, and if I go up 2, 1, 2, and over 1, I'm right there. If I go down 2, 1, 2, and over 1, I should be right there. I'm not real good at drawing these, so there you go. Okay, there's my slope there. That kind of makes sense. How about f prime at 1. Well, that would be -2 times +1, or -2, and that pen is done, and I'm throwing it away. Okay, so that one would be here, so down to right 1 and up to right 1 would put this one like this. That kind of fits. Okay, how about just for grins and giggles, we find, I'm running out of colors here. Well, the yellow didn't work too badly. What about f prime at 2? Well, that would be -2 times 2, or -4. So when I'm at 2, my slope turns, here's 2, wait a minute, 1, 2. So here's my slope, here's where I'm going. My slope turns into 4. 1, 2, 3, 4, and over 1. Oh, that makes perfect sense. 1, 2, 3, 4, and over 1, 1. It goes right through there. That makes perfect sense. Again, you can do this on your calculator just as easily. Sometimes it's easier for me, though, to do it on a graph so you can actually see what's happening. And it's not driving you totally crazy because you're trying to keep up with the calculator stuff. So that's pretty cool if you ask me. Now, do you see the advantage to creating an equation rather than having to do this thing 1, 2, 3, 4 different times? I don't know about you, but I think that equation makes it a lot easier. Again, the derivative equation is what allows us to find slopes of tangent lines very, very, very quickly. We don't have to keep repeating the process. We just have to plug them into the equation that we found. Questions at this point? Okay, well, I have a little tiny bit of an assignment for you, but it's not much. I just want you to try a couple. Okay, don't freak out. These are ones we're going to look at in class. So of these 4, I don't care which ones, pick 2. Pick any 2 you want, write them down on a piece of paper, and try them before I see you on Monday, or Tuesday. I will see you on Tuesday. That is my plan, my wholeheartedly, I feel like it, I feel it in my bones. I'm going to see you on Tuesday. Yes? Yay? I would be so much happier. Pick any 2, I don't care which 2, just pick 2 of those and try those 2 for class time, and we'll pick up there on Tuesday. I have the answers. I actually have the answers covered up right now, and I will show those to you, but I want you to try them first. See if you can do them. Pick 2 of them and find the derivative. Write the equation out. You're going to do this equation right here. You're going to find an equation like this. Okay, you're gonna plug them, you're gonna put them into that, and you're gonna try to find the equation. Okay? Any questions?
So we're not doing the worksheet that you attached?
Not yet.
Okay.
We're not there yet. I don't know, what did I attach? Did I attach? 3-1. Yeah, we're not there yet. We're fine. We're fine. Nope, we're not ready for that, but I didn't know how far we would get, so I thought, well, I'd rather be prepared than not. Okay? All right. We will take a deep breath. You guys are all feeling okay and everybody's doing good? Awesome. Okay. Well,
I've been in this hole for 3 months, so.
I'm sorry. I don't know how to help you there. I don't know how to help you there. I'd like for you to be here too, so I get it. Okay, my plan is to see you then on Tuesday, and we'll clean up anything we need to clean up and move forward. So we're doing great. I have several more pages of this section, so I'm not ready to wrap it up yet, but I have a feeling I am intending to test you on next Friday over the end of chapter 2 and section 1 of chapter 3. That is my intent at this point, is to have a test on Friday over 2.5, 2.6, 2.7, and 3.1. Make sense? Okay. Hey, have a great time. I will see you on Tuesday, because I really, 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 really want to see you on Tuesday.
Okay, see ya.
Bye, guys.
Bye.